Good morning to all. Today I will explain the program. The program name is controlling brightness of LED. So here today I will explain the program. The program name is controlling brightness of LED. So here as include lpc214x.h. So that means to define the header file lpc2148. So here we are using the interrupt request mode underscore IRQ void PWM underscore ISR of void. So here if PWMIR and 0x001, if interrupt due to PWM 0, so then open the loop PWMIR is equal to 0x001 to clear the PWM 0 interrupt. So if another interrupt came means that time if PWMIR and 0x002, if interrupt due to PWM, that time PWMIR is equal to 0x002 to clear the PWM1 interrupt. Then another interrupt came means if PWMIR and 0x004, if interrupt due to PWM2, PWMIR is equal to 0x004, clear the PWM2 interrupt. So here we have created 4 interrupts, that is PWM0, PWM1, PWM2, another interrupt is the PWM3. So if PWMIR and 0x008, if interrupt due to PWM3, then open the loop PWMIR is equal to 0x008, clear the PWM3 interrupt. So close the loop VIC vector address is equal to 0x000. So here close the loop. So here whenever here we return the main program, whenever interrupt occurred, it call the that interrupt sub program. Okay, so that interrupts are PWM0, PWM1, PWM2, PWM3. So here observe the int main of void, open the loop VPB div is equal to 0x00002, VPB div is equal to 0x0002, pin select 0 is equal to pin select 0, 0x008008. Configure the port 0.1 and port 0.7 as PWM3 and PWM2 respectively. For two interrupts you are connected, the ports are port 0.1 and port 0.7, that is PWM3 and PWM2. So then VIC vector address 0 is equal to unsigned PWM underscore ISR. Okay, here we are given the PWM ISR address. VIR VGCT CNT 10 is equal to 0x0020, here 8. Okay, enable PWM IRQ slot. Okay, so here enable the PWM IRQ slot. That means here whenever it is enabled, that PWM have the 4 interrupts, PWM0, PWM1, PWM2, PWM3. So whenever it required that interrupt, it call the that subroutine program. Okay, suppose it required the PWM2 interrupt is enabled, that time it call the this program PWM2 interrupt. Okay, so again here VIC int select is equal to VIC int select is equal VIC int select or 0x000, PWM configured as IRQ, it configured as interrupt request mode. Okay, so here whenever VIC int enable or 0x00100, that time it enable the PWM interrupt. Another condition is VIC int select is equal to VIC int select or 0x000, that time it configured as interrupt request mode. So here for PWM3 WH, okay, so PWM TCR timer control register is equal to 0x02, reset and disable the counter for PWM. Okay, it reset the value and disable the counter. Then PWM PR is equal to 0x1D, prescaler value for 1 microsecond. Here we are mentioning the PR means prescaler value is the 1 microsecond and clock frequency is the 30 MHz. Then PWM MR0 equal to master register equal to 10000, time period of PWM wave. So that is given 100 millisecond. So the next step is PWM MR2 is equal to 40000, rising edge of the WH control PWM. Then PWM MR3 is equal to 80000, falling edge of the WH control PWM. Then PWM MMCR, master control register 0x000243, reset and interrupt on the MR0 match, interrupt on MR2 and MR3 match. So whenever it reset, it should be match the MR2, master register 2 and master register 3 match. Okay. Then PWM LER 0x0D, latch enable for PWM2, PWM3 and PWM0. It should be enable these interrupts. Okay. PWM PCR is equal 0x0C08, enable PWM3, PWM2 and PWM0, double controlled PWM1 and PWM3. So then PWM TCR is equal to 0x09, enable PWM1 counter while off 1. It is the unconditional statement, continuously it execute, it will not terminate the loop. So here we written the control brightness of LED. Here we are created 4 interrupts, PWM0, PWM1, PWM2, PWM3. So whenever you are taking the pulse width modulation, it contains the on and off, T on and T off. So whenever you are taking the T on, WH is there, and also whenever T off means double falling is there. So that's why here observe here 2 and 3, PWM2 and PWM3 is the reset interrupt. Okay. So whenever here you are taking the edging triggering and fall triggering, rising edging. So whenever you observe the pulse width waveform, here 0 to 1, that is edge triggering, rising edge. So whenever 0 to 1, fall edge triggering. Okay. So like that here pulse width modulation, it is the T on plus T off. So by here T on plus T off. Okay. So that means the duty cycle from 0 to 100%. For 0% LED will not glow. Whenever it came slowly increasing, that means if you are taking 10 or 20, if you are taking 25%, 25K means duty cycle 25 means the LED will be go brightness. If it is 50%, the LED will glow, increase the brightness. If it is 75% came, the LED will increase more brightness. If it is duty cycle is equal to 100%, the LED will give full brightness of the light. Okay. So go to debug menu and click on the start debug session. The program code size will be occupied 32 kilobytes. Okay. So here go to debug menu again, run the command, observe the output. Okay. Port 0.2 and port 0.7. Okay. Observe this output. Observe the output. Okay. Here continuously T on T off. Okay. So already in program I said that was taken 100 millisecond. Every 100 millisecond it will go 0 to 1 is the rising edge triggering, and also 1 to 0 means false triggering. Always T on T off will appear. So that means like that here it increase the brightness of the LED 0 to 100%. Here observe the PWM output. So like that here 0 volts to 3.3 volts, initially 0% duty cycle. That time LED output is the no brightness, off position. Whenever the duty cycle will be increased, so 25%, the LED will be increased somewhat brightness. So whenever it came 50%, that time it increases the brightness. Again 75%, it will increase the more brightness. If it is 100% duty cycle, the LED will give full brightness. Okay, so here, so that depend on the if you are taking the ARM processor will give the digital value. Initially 0 means 0%. If it is given the 64 value, so then it convert to the output analog signal. So and it will give the 25%. The LED will be slowly increase brightness. If it is digital value is the 127, that time LED will depend, the brightness will depend on the duty cycle. Here it came 50% duty cycle and digital value is the 127 and it converts to analog value. Then LED brightness will be increased. Then again the 75% duty cycle, that time digital value is the 191, then output LED more brightness is increased. If it is 100% duty cycle, so that time digital value is the 255 and it converts to analog form, then LED will give full brightness of the light. Thank you.